Hey everyone, my name is Muhammad Ali. I'm a solutions architect at ClickHouse. In this demo, we're going to talk about data observability. Data observability is the capability to understand, monitor, manage the health and reliability and quality of the data across your data platform, from the ingestion to the consumption. The goal here is to minimize the downtime, which is a situation where your data in the platform is either not available or bad, but in both cases, there can be severe business consequences. With data observability in place, you can detect data problems or system failures in real time and quickly investigate the root causes. For that, you should have your platform sending you continuous real-time signals from the pipelines and the infrastructure components, and as well as the quality metrics of the data. You'd collect these signals using open source tools such as OpenTelemetry, which is an industry standard for collecting application and infrastructure signals. And for the data quality, you could use any of the popular data quality frameworks such as Great Expectations, SOTA, DQ. And for the lineage, you could use OpenLineage. We will be using ClickStack, which is a popular open source high-performance observability platform built by ClickHouse. ClickStack is a fully compatible tool with OpenTelemetry, and you can serve it as a backend for all your infrastructure and data pipeline health signals, which are generally logs, traces, and metrics. ClickStack uses ClickHouse as the backend, and you could use it to store quality metrics as well that you can collect from your choice of quality framework with little code. In our demo, we will see a typical data lake with bronze, silver, and gold layer. We would land the data into a landing area from where the data from these three sources, transactions, customers, and product balances, will be ingested in the data lake. This is a typical banking use case. We use Airflow to orchestrate the data pipelines and have written the processing code in Spark and dbt, which uses Trino as our query engine for processing some of the data. At the end, we produce a customer 360-degree dashboard, which could be used by our decision makers. Our DAGs are very similar, all process data from one layer and writes to another. Before we run our processing, we check the availability of the data, and after we have processed the data, we validate and emit the performance metrics of the data and the pipeline to our ClickHouse-based backend. We have a nice looking dashboard which offers insights over our customers and the segments. So how do we collect the signals? We capture Airflow, Spark, dbt, and Trino telemetry using OpenTelemetry. And we use Great Expectation framework to run the quality checks and report it back to the ClickHouse. These signals flow in real time to ClickHouse, and we use HyperDX, which is a purpose-built front end for exploring and visualizing observability data. This demo will be focused on observability of the platform, which is achieved through collecting telemetry from all moving parts of your data lake. We have instrumented orchestration layer, which is Airflow, our infrastructure that is running our jobs, the query engine, in this case is Trino, and we have instrumented every task in Airflow DAGs with logs and traces that gives us deeper insights into what is happening inside each of these tasks during the data processing workflow. So let's get right into it. As I said, we are using Airflow as our main orchestration engine. We have a bunch of DAGs that process the data and move the data from lending all the way to gold and into those dashboards. Now, we've instrumented Airflow with OpenTelemetry, and what it does, it actually creates traces on every DAG run by itself. In the DAG code, which is Python, we are importing the OpenTelemetry SDK, the tracer, and the logger. In each task, we're going to create a span, which will become part of that DAG trace. Now, every time we log it within this task, it's going to report against this particular span. Now, what it allows us to do is in HyperDX, we can visualize all of that in a single UI. And all of the spans show us the tasks. And now you can, with the single view, can identify which task is taking longer and which task has actually failed. We can enrich this trace data with additional information, such as here we're sending what some metrics around how many rows are processed within this particular task. This is HyperDX, our purpose-built observability user experience. We have built a dashboard that keeps an eye on our customer 360 pipeline. Airflow is sending us the telemetry, and we are able to visualize all the DAGs and individual DAGs execution duration times. We also have data from the logs within the tasks, and we are visualizing that just to keep an eye on the different errors that may happen in the log. We're also keeping an eye on traces and some system resources such as Spark and Trino execution queries. HyperDX allows you to interact with these dashboards. You can drill down to a specific time window of interest and it will update all the other charts on the dashboard. With the tabular data, you can drill into the values and it automatically navigates you to the search experience, and it will filter the data on the value that you've just clicked in the dashboard. In our case, it is a DAG ID, and now we're seeing traces of this particular DAG. Now, this is where the propagation of the traces come in super handy. What you are seeing is a trace span visualization that shows you all the events within a particular trace captured against all the spans of this particular trace. Airflow DAG is the trace, and each task run is a span. All log lines written in the task code are shown under its respective span. You can see most time spent in our DAG is Apache Spark job, which completely makes sense. Now I'll navigate back to the dashboard and show you how I have set up alerting on this dashboard for the known issues. ClickStack team is working on anomaly detection capability, which will allow you to set up alerts on unknown issues as well. We have this database error chart. Within here, I have created an alert. The logic is very simple. I have asked HyperDX to alert me in case there are more than one log line with database error in the last 5 minutes. The alert is sent through the webhook to my Slack channel, and you can potentially send the alert to pretty much anything that has webhook support. Now let's get back to our data lake and create a failure scenario to see if we have received an alert. I'm going to kill Trino service, which will fail the queries that are coming from the DAG, resulting in database errors, which should send us an alert in Slack. We would wait for the DAG to launch and send some error logs. And now I have a Slack message, which is the alert from HyperDX indicating a database error. When I click the link in the Slack message, it would navigate me into the same dashboard that sent the alert. You can see the database error chart is displaying more than one error. Here I can see a DAG that is run, which I can click and drill down to get more details. Now I can open the trace and it would show me the complete flow of the DAG as we saw before, with a few log lines which are in red color indicating some issue. I could also search the error using the full text search. Now, when I click a log line after searching the database error, since the log line has the trace and span context, which is the instrumentation that we've done in the DAGs, I can see exactly in the DAG where did that error occur. I have also an option to see surrounding context, which shows me the error message that I'm interested in and whatever happened 15 seconds before and after. This gives me a good indication that my Trino service is refusing HTTP connection. Now, this is a very simple scenario, but you could think of debugging complex issues using the same workflow. Once I will restart the Trino and rerun my DAGs, the error should disappear. Now, with that, I showed you were able to set up alert, receive the alerts in tool of your choice, and then debug using our trace, search, and the dashboard capability in ClickStack. Thank you for taking time to watch this demo. If you need more information, please contact your local ClickHouse team. Thank you.